Hey guys, I'm just going to do a quick review of the first part of this assignment. So last Thursday you guys got an assignment called 2.2. It was like a copy out of a book. If you don't have this assignment from last week, you will need to go to my website at listener.weebly.com and you will need to print it off. So do that before you go through this video. So this first video is just going to be kind of a review of what we talked about on Thursday, just to kind of remind ourselves and get back up to speed so that we can go on to the new section. So we're going to start in this first section. It says, in exercises 1 through 10, determine which functions are polynomials, and for those that are polynomials, state their degree. So if they're not a polynomial, we don't need to worry about stating the degree because it doesn't make sense to state the degree if it's not. So remember, there are two things that make these polynomials. The first thing you want to look at is the exponents. So if you look at the exponents that are on these x values, if those numbers are whole numbers and they're positive numbers, then this will be a polynomial. So this one is a polynomial. The second thing it asks is, if it is a polynomial, state the degree. So ordinarily, if we're looking at a polynomial function, it's in what's called standard form. So if you look down here at, say, number 14, number 14 is in standard form. It has negative 2x cubed plus 4x squared minus 6x. The 3 here is the highest exponent. It goes to the next highest and then to the last one. So the highest exponent tells you the degree. Hi. All right, sorry about that. I had a couple visitors. Anyway, so if it's in that standard form, you just look at the highest degree. That's the degree of the function. But notice that number 1 is not in that form. We have x plus 2 cubed times x minus 3/5 squared. Because it's in this different form, in order to find the degree, we're going to have to count how many times x is being multiplied together. So this first x, because it's raised to the third power, is going to be multiplied together 3 times. The second x will be multiplied together 2 times, and since there's 3 here and 2 here, altogether it's going to be multiplied together 5 times. So the degree here on number 1 is 5. Okay, so you have to have a different method depending on, sorry, I gotta fix that. So depending on which form it's written in. So number 2, again, 4 and 2 are positive whole numbers. So this is a polynomial, and its degree would be 4 plus 2, which is 6. If I look down at, say, number 6 is raised to the 1/2 power. Because that exponent is a fraction, it's not a whole number, this is not a polynomial. Number 5, our x is under a square root, and if you remember, that is the same as x to the 1/2 power, right? It's the second root in the first power, so I can write it as x to the 1/2, so that would also not be a function. On number 8, x is on the bottom of a fraction, and if you guys remember that when you have x on the bottom, another way to write that would be x to the negative first power. So again, not a polynomial. Okay, so that's the first thing that we talked about on Thursday. The next part we did was we matched these functions to their graphs. And the way that we did that was we looked at the end behavior. So we first talked about our two functions. What's the difference between x squared and x to the third? Well, x squared, as you know, is that U shape. And then x to the third power is this little line that kind of jogs. It goes left, down, and right up. So if we think about these functions as my base functions, whatever the degree is, if it's even, the ends of the function are going to do the same thing that the ends of x squared do. They're both going to end up. If I put a negative in front of x squared, you know that flips it, right? So if there's a negative, both ends will be down. And then here, if I were to flip this as negative x to the third, this side would be up and this side would be down. So I can use that pattern on all of these functions, even on these ones that have a higher degree than 2 or 3. Anyone that is even is going to have the same end behavior as x squared. So that's for the degree. So if the degree is even, then it will have the same end behavior as x squared. If the degree is odd, it will have the same end behavior as x to the third power. Now, it won't look exactly the same in the middle of the graph. There may be other things going on. There may be little turns like this, little jogs in our U-shape because the degree is higher, but the ends will still end up the same way. So if I look at number 11, negative 3x to the first power, right, if I don't see an exponent, it's a 1. It's an odd degree, and it's been flipped, so it means the ends, the left should be up and the right should be down. So h, first of all, because it's linear, right, we know that's a line, but also the ends are doing what we expect them to based on the even and odd and positive and negative. Number 12 is quadratic, so I expect this to be a U-shape. It has a negative out front, so it should be upside down. So C looks a little bit like it, but again, it has that jog in it, so I'm guessing that it's probably not that one. It's probably G, because G is just strictly a U, and it's upside down. Now 17 has an even degree, and it's negative out front, so I know both ends should go down, so this would have to match with C. 18 is fifth degree, which is an odd degree, so I know that the left should be down and the right should be up because there's no negative in front here. So we're just looking at the highest degree of the entire polynomial. That's the one that we count, so I wouldn't look at the 3 or the 1 here. And then I look out front, right after the equal sign, or right in front of the first x, is it positive or negative? So because this one is positive and fifth degree, I know the left should be down and the right should be up. So it could be A or E, but since E is just more smooth, I'm going to assume that's probably one that is x to the third. So that would probably be like 15 would probably be E. And this one here, A, would probably match with 18. All right, so the next thing we talked about on Thursday was we talked about, or actually I think this was the day before. We're going to skip down here. We're going to look at 25 through 36. We found real zeros and stated their multiplicities. So if you remember, zeros and solutions to the function are the same thing. They're just different names for the same thing. We call them zeros because if I were to set this equal to 0, I'm looking for the values of x that make it equal 0. So that's why we call them real zeros. So again, they're solutions. We also sometimes call them x-intercepts. So if we're looking at the graph of these functions, these solutions or zeros that we find will be the places where the function crosses the x-axis. So if I were to set this equal to 0 and try to find x values that makes each individual factor, so 2 is a factor, x minus 3 is a factor, x plus 4 is a factor, I need to find what would make each of these equal to 0. So for this one right here, it would be x equals 3 because 3 minus 3 is 0. For this one right here, it would be x equals negative 4 because negative 4 plus 4 is 0. This 2 out front, there's no x with it, and so it's not going to have a 0 with it. Only if there's an x with it will it be included with our zeros. Now it's also asking us to state the multiplicities. The multiplicities is talking about how many times does this 0 happen. So the first one is just once because it's just x minus 3, but the second one, x plus 4 cubed, that's the same as x plus 4 times x plus 4 times x plus 4, right? So that 0 of negative 4 happens for this polynomial 3 times. So that's what we call the multiplicity. So this 0 or solution of x equals negative 4 has multiplicity of 3. And again, we get that from our exponent. So if we come over here to number 27, we have a 4x squared out front. Notice the difference. This one just had a 2, right? It didn't have x with it. It's just a 2. But this one here has a 4 and an x squared. So the x squared is the reason that this one will give us a 0. So if I take 4x squared and set it equal to 0, what would x have to equal in order to make that true? Well, x would have to be 0. And because it's squared, that happens twice. So this one would be 0 multiplicity 2. Then I have x minus 7, so that would be x equals 7, and that one also has multiplicity 2. And then I have x plus 4, which means negative 4 would also have to be 0. X plus 4 just happens once, so I don't need to write a multiplicity on it. Notice that the degree of the function, which would be 2 plus 1, which is 5, the degree of the function also tells me how many zeros there should be. So there's 2 that are 0, plus 2 that are 7, plus negative 4. So 2, 2, 7, 7, and negative 4 are the 5 zeros for this function. We just write, since 2 happened twice, we just write that as 0 multiplicity 2. Oops, sorry, I made a mistake. That should be 0 and 0. The 0 is 0. The multiplicity is 2. So 0 is a 0 2 times. Sorry about that. All right, so moving on. If we have something like this, number 32, and we are asked to state the zeros and their multiplicities, we can still do that, but we can't do it with the form it's written in. So in order to be able to see where the zeros are, it would have to be in this other form, which is called factored form, right? So we're going to factor 2x to the fourth plus 5x cubed minus 3x squared to get it in this form so that we can then see what the zeros are. So if you remember, the first thing you need to do anytime you're factoring is look for common factors. I'm just going to kind of get rid of this to get out of our way so we can work with this underneath. So the first thing is look for the common factor. 2, 5, and 3 do not have any common factors, but x to the fourth, x to the third, and x squared have an x squared in common. So I can pull that x squared out, which would leave 2x squared plus 5x minus 3. Now this part inside here, we're going to x factor. So remember when we're x factoring, we take a, which is in front of x squared. Oops, let's circle it. Oh, I'm just making a mess. And we take the negative 3, so 2 times negative 3 is negative 6. And then our b goes down here. So we're looking for two numbers that multiply to negative 6 and add to 5. So we're going to either use 2 times 3 or 6 times 1, but we need our signs to work out. I know one of the numbers has to be negative, so that's going to take 2 and 3 out of the running, because if one of them is negative and one of them is positive, their difference is 1, and we need a 5. So for 6 and 1, if I do my 1 as a negative 1, 6 times negative 1 equals negative 6, but 6 minus 1 is 5. So 6 and negative 1 are my factors that I was looking for. I still have that x squared out front, but now I'm going to write this middle piece in factored form. So I would have x minus 6, x plus 6, that was a positive 6, and then x minus 1. And then remember, if a is not 1, remember it was 2, we have to divide both of these by a. If it goes in evenly, we're just going to divide it in. So this would be x plus 3 because 6 divided by 2 is 3. But since this 2 doesn't go evenly into this 1, I'm going to move the 2 in front of x. This would be 2x minus 1. So now I have factored form, and since it's now in factored form, now I can find the zeros and I can state their multiplicities. So remember, for x out front, that's just going to be 0, and because it's squared, that would be multiplicity 2. X plus 3, my 0 would be x equals negative 3, and because it doesn't have an exponent, it doesn't have a multiplicity, it just happens one time. For 2x minus 1, remember I would need to set 2x minus 1 equal to 0 to find the x value that makes that work. Add 1 to both sides, so 2x equals 1, and then divide by 2. So x equals 1/2 is my fourth 0. So these are the zeros. They all have multiplicity 1 except for 0, which has a multiplicity 2. The last thing that we did on, I can't remember if it was Wednesday or Thursday, is that we talked about if I'm given the zeros, how do I then find the polynomial that goes along with it? So basically, it's going backwards from what we did from 25 to 36. in these ones we're given the polynomial and we're asked to find the zeros. Here we're given the zeros and we need to use it to find a polynomial that it could have come from. So if my 0 is -3, then I know the factor it came from must have been x plus 3. If my 0 is 0, I know it was probably just an x. For 1, it would be x minus 1. And for 2, keep that button. And for 2, it would be x minus 2. So I could write this in any order. It doesn't matter which one is first, second, third, fourth, as long as they're all there. I could multiply them all out, but since there's 4 terms and 3 of them have 2 terms, that would take a lot of multiplying. So we'll just leave it like this in this form. And then, so again, you don't need to do this section of this worksheet on your own, but I just wanted to remind you from the previous section. So if you're working on 2.2a, this will help you. And that way you'll kind of get a review before we go on to the next part that we'll use some of this stuff. If you're given a 0 of -2 and it has a multiplicity, so remember that means it happens more than once. So from -2, for -2, the 0 would be x plus 2. But then the next part of that question is saying that the multiplicity is 3, so I know that that one would have to be cubed. Same thing for 0. If it's 0, I know there's going to be an x out here, and since it's multiplicity 2, it would be squared. Okay, so that's kind of just a quick refresher. In the next video, we are going to go over the new part, which will be in exercises 51 through 72. So tune into that one to learn how to do that, the last part.